fun. This thing is, I love this thing. It's so DIY. I love this. So cool. I love it. We have a box now. We have a box of all of our experiments. This is the ventilation mod box. This is the first one. This is the second one. This is the third one. This one actually reduced fan speed, but we saw maybe 1 degree delta on that one. This one you've never seen. This is the 4.0. This has a attachment right here, so it clamps onto the Steam Deck. Pretty cool. This one actually saw a 3 to 4, and then this one right here is the better version of this one, which is a 5.0. I alluded to this in our pull-up challenge video, and yeah, it worked really rather well. Worked rather well, just as slightly better than this one, but I thought I could make it better, and we came up with this one. This was with a different size fan, but with what happened with this one, this is the 6.0, pretty similar to this in a lot of ways, set to use the larger fan. And the thing is, with the larger fan, we only saw an increase of a delta of 1 to 2 degrees. So I was like, what is going on here? Why is a fan, this bad boy, look at this behemoth. This thing is huge. It's enormous. It's way, 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 way bigger than the last one. The last one's this size. Look at this thing. So this thing with this mod was only getting maybe 2 degrees cooler. And this one, so as tiny as it is, was keeping up pretty well with this one. So I was like, okay, there's got to be an issue with my application. So I don't even know if I'm going to release those videos, but this was, in my opinion, they're failures. So went back into the drawing board and I created this thing. This is the first edition of the 7.0. It is just a housing shell, and if you can see, there's a huge difference between the two. Obviously, first of all, there is no mounts yet done for this one. I need to do proof of concept first before I start spending the time creating a nice shell for it, like this. Super nice shell. It's going to be pretty much the same kind of setup as it was with this one. It's going to look very similar to this. But I just needed to make sure that this thing worked better before I went ahead and spent the time on it. This thing kind of took me about an hour to figure out, and I actually had to print it twice, and we're going to test this thing out. So we've got our Steam Deck heating up. Wow, it's already at 85. What we're going to do is we're going to do our good old-fashioned rubber band trick. But before I put this on, I'm going to show you how well this one worked. It's a really cool mod. I'm a big fan of this mod. So if you saw the pull-up video, you've seen this, and you also know we're doing some type of giveaway with this. But I've made some changes, and we will not be giving away this one per se. I want to make some upgrades, which is actually this video, and see if we can make it slightly better. So, but the cool thing about this mod is its mounting mechanism. So it goes, grab your Steam Deck. You hook this over your vent, pull this over down here, and boom. Pretty legit. Pretty legit. And real quick, we don't have thermal pads behind this heat plate. It's very cool to the touch. There is the air gap there. So it's basically a stock Steam Deck now. But like I said, this one had like 3 to 4 degree drop, which was good. I was happy with that. But the fact that the larger version one I made with the bigger fan, this one didn't have that much of a better result, gave me the thought that our application of how this covers this fan hole was not that great. So that's why we went back to the drawing board, and by we I mean me, and I created this thing. This one actually goes over the vent fans, and this took me a couple attempts. I think this was the 5th version to get a pretty good seat. Obviously we want to create some type of gasket on the last version. So what I'm thinking, a gasket around here, and what we're probably going to do is probably just make a channel where we can stick a rubber band. But as you can see, these slots right here in the very bottom right here, we're going to go ahead and it slides into the 2 furthest hole ventilation holes, and now this thing doesn't want to slide off. It's actually pretty dang snug now. But before we do that, we need to take some temps real fast before we get too carried away. So I'm gonna plug this thing back in first, see what it's like with our new cooler. This fan is 6,000 RPMs and it's just gonna go full tilt. There's no control to this thing. It's all go. If you saw our last JSOX video, there's literally no point in putting the fan in anything but maximum speed. No point whatsoever. So we got a pretty good seal there. So we're gonna plug this bad boy in and let's see how quickly, if at all, the temperature drops. So we're looking to see to beat a delta of 3 to 4. So right now we have a dB of 48 roughly. What we're hoping for is delta at least 5 to 6 with this fan. We've only been running for a couple minutes and we have a delta of 3 and a fan speed drop of 4400, which is kind of what we're seeing on our last testing, to be honest. Our dB, which I think is the most important, is at 51. All right, so we hit 4 delta. If I can get a delta of 6 for sure, what I'm gonna do is continue working on this so it's something as sleek as this, which wouldn't be so hard. Basically, just imagine me taking this guts right here and just putting it inside here. It's not that crazy, but what the only problem is this thing's gonna get taller. Channel right here is kind of a choke, kind of choking it down here. So probably not the best design I made here, but now that I think about it, because this thing is super just pretty aggressive right here, but the fan is right on top, so it's like plus and minuses, right? Definitely that's something we could work. If I can see 76 here, a 6-degree delta. Okay guys, I think we'll give it that. We'll give it 74, 75. So we do have a delta of 4. It's kind of on the fence for me on whether or not we should keep working on this one. I think we can make some design changes, but before we do anything, I'm just gonna take a look at our actual seal. Are we blocking this fan in any way? I didn't really take a look at this when I was designing this, and this might be a huge undersight for myself. And yeah, I am so stupid. So this vent cover, yes, it fits here. You see this gap right here, sliding it up and down. You can see, one thing you'll notice about this gap, you never see the edge of the circle. So this vent is actually clogging it slightly, because these two are the exact same size. So my dumbass didn't design this well. So that sucks. Let's try this again. And just say goodbye to this bukkake mess right here. This one's done. That's why we don't spend too much time on it, because it's not a good design. You don't want to waste too much time on it, so you just need to get it running well enough for it to do its job. And that way you don't waste time, mostly time, but you don't waste filament as well. I got some really high hopes on this design. I'm thinking this is going to be great. Cool, so it's a pretty good seal there. Okay, so only thing I'm going to do is I'm going to put a bit of tape out in the front to make a better seal. We're going to give this thing the best chance we can. The reason why we made it this chamber style is mainly so that there was less play, less move for the air to go, and it would be more likely to get sucked into there. The question is having a big open one versus having a small slit opening, which one's better? You know, I would argue that this one is better, but here's the problem. This one has a lot less suction. This one has more suction because there's more resistance. So, you know, it's kind of hard to say which one is the best. So our fan speed just dropped to 44. That's kind of what happened with both of these. Right now we're at delta of 4. The question is it better to have a small mouth or a big mouth? This one worked great, 3 to 4 degree delta with this fan on, and it's basically exactly what we see here with this one and this one. The modifications that we did with this one, is it going to be better than either one of these? We're already seeing a delta of 3 to 4 on both of these, which is not a crazy amount, but when you tie it on with a fan speed ramp up to a dB that's equal to both, then you're going to start seeing some real big benefits. But I want to see if our changes from this design to this design made anything huge. Mainly this curve is probably going to be a big thing, and the gap here is a lot larger now on the new one versus this one. So those are two things I'm really interested to see, that if it helps us with overall temperatures. So let's see if we seal it up better, and we get a noticeable difference if we seal the air gaps. meaning if we had one that was airtight, we could do it one of two ways. We could create a gasket. Oh my god, it's already better. So we got that 74 easily out of it. So definitely having a better gasket does help. Definitely going to be a thought on the next one. I think we could do it with rubber bands, or even if we put like a piece of electrical tape or even duct tape on the edge, that would help a lot. Be a better. It wouldn't be as good as this seal, but it works. Right now we're at delta of 5, which is better than any of these two. So that's a good sign that we're moving in the right direction. Fan speed has dropped too. Maybe that's, oh, you know what? I didn't look at the fan speed. This test is really stupid with or without. Like, honestly, the more and more I do this, it's like with an external fan, the better this external fan is, slower the internal fan goes, which it's kind of like one step forward, one step back. You know what I mean? Like it's really kind of fighting against each other. So what we're going to do for this testing as we move forward is we're going to change the testing completely. We're going to change the testing. So let's go listen to the dB right now. So we're at 50 decibels, and then we're going to ramp up this fan speed to 4400, whatever that is on this thing. The closest we can get to 4400. So what we're going to try to do is, with this fan, we know we can get around that 4 to 5, but the problem is this is reducing air resistance so much that it's dropping overall fan speed. So it's kind of like one step forward, one step back. So to overcome that, we need to manually lock our fan. So right now, this thing is humming at 50 dB. So what we're going to do is we're going to increase this fan until we don't exceed 50 dB fan noise. Okay, right now we're teetering between 51. So we're at 5,400 RPMs. I'm gonna leave it there. Okay, so right now we're getting a hell of a lot better temps. We're at 8 delta right now. We pegged our fan speed, and we're only slightly above by 1 dB. I'm not gonna mess around with it too much because this fantastic app is really, really twitchy. Just for context, let's talk about the dB on JSOC's cooler dB. So the fan on max speed dB was 56 dB, 5 dB quieter. Yeah, the gasket helped quite a bit, huh? Interesting. Remember, this fan is tiny. This is a baby fan. I feel comfortable saying with the gasket we can easily hit the 71. Right now, with our current temps, we're as good as the JSOC's backplate on medium. The only time this thing beats us out is when it's on high. This is only 2 degrees cooler on high versus what we have going on here. So maybe we'll hit 70, I don't know. But remember, this testing is just, we're sitting on the screen just staring at it. We're not really doing anything dynamic. This is a very static test, you know. It's not a really real world test. It's just a repeatable test. That's what we're going for. The next thing I'm going to test, if I don't see it hit 70, next thing we're going to test is fan speed at 100%. So we're going to try to hit 7,000 RPM on the fan speed and see how much cooler this can get the Steam Deck. 6,900 RPMs, 53 dB. So we won't be hitting the same noise. We'll be only going 2 dB higher. But then if you're already hearing something that's around that 51 range, 2 dB is not going to make that much of a difference for you. Hit that 70, that's 9. That's a 9. Think about it. This fan is $3. The amount of filament this costs pennies, 10 cents in filament. I think the rubber bands cost more than the plastic. I'm gonna call it here at 71. So we get a delta of 8, and then we're gonna go for a max RPM now. Oh wait, is it just going to max if I just leave that blank? Oh my god. If you just leave it blank, it just goes to max. Alright, there we go, 7,000 RPMs. Okay, let's get dB. We'll call it 53.5. It's closer to 54 actually. We'll just put 54 to be cautious. We have a delta of 10. So in our previous testing, without our new exhaust cooler, if we put our fans at max, we had an automatic delta of 8. So that's what you get. Max speed, delta of 8. Right now we're hitting a delta 11. So our setup here is better. So this exhaust fan is giving us 3 more degrees a delta when you combine the two. But remember, if you just put your fans at 7,000 RPMs out the gate and you don't care about noise, you can get a delta of 8 automatically in Witcher 3. 68, wow. A steady 11 degree delta would be a big W in my opinion for this mod. Now that would give me the but the willpower to redesign this again with the changes we've made. Clearly this style is a lot more beneficial than this style. And I think it all has to do with suction, because there's less air resistance in here. There's more air resistance with this style. So meaning the fan's going to want to pull a lot more air, the external fan, than this one. If you look at the JSOCs, they did something very similar. Very small port, it really constricts the air here. And what happens is all this air gets sucked down into here and then get pushed out to the top. And this thing is like basically sucking air through this wall, this cavity right here. All right, I think that's and we might be able to get 12-degree delta, but I'm not trying to wait that long, y'all. It shows that this works. That's more than enough for me. Man, my phone's going nuts. I think what we need to understand here, I think the main thing about this whole external fan setup, whether it's a JSOCs or gonna be our little DIY, is noise. It's overall noise. Okay, so whether it's this, or just using your stock fan on high, noise. So if you don't care about noise, then by all means, you should do one of these, or stay tuned because we're going to be giving some of these away once we get them reconfigured for this model. Something that you can easily attach and detach from your Steam Deck, or you can spend the money and get a JSOCs one, which honestly, in my opinion, is if the price and the noise is not an issue for you, then definitely this is a good avenue for you as well. But with one of these that we created, we got a delta with the stock fan without decky. We got a delta of 5 across the board with a fan speed reduction of 400 RPMs, meaning we hit a fan speed of 4,400 from 4,800 in the room temperature of 21.5. When we added this fan plus the Fantastic app, setting the RPMs to 5,400 RPMs, which was only 1 decibel louder with just this fan on, we saw an even bigger delta of 8 degrees. So a 8-degree delta with this and our RPM set at 5,400 in a room temp of 21.5. But when we went balls to the wall with our stock fan with this, then we saw the biggest gap where we saw a delta of 11 with a fan speed of 7,000 RPMs and a dB increase of 3 from 51 to 54, which is not that big of a dB increase. For example, this fan full speed plus this fan full speed is 56 dB. So we're only off by 2, but this thing costs $59.99, $49.99. Say $59. If you're gonna advertise $50.99, this thing's costs $59.99. This costs $50. This doesn't. This is pennies. And like I said, figured out how I want it to look, and we get a really good one. Well, we already have a good design. We just got to incorporate these new design changes into this one, and then we already got a great running system. This thing is, I love this thing. It's pretty so DIY. I love this. So cool. I love it. And we're going to give these away for free. I will not be releasing the STLs on this, and I will not be selling these. These are only for my viewers, and it's only going to be for you guys. Not going to sell it. And the main reason why I won't be selling this is, honestly, guys, I don't really see the value too much in these. And it kind of in all of these for me, I don't really see too much of a value, even though, you know, they have their own points. But for me, especially, audio was a huge thing. Like, these things are super loud. I don't like that. It's not for me. So I guess I'm like not a good example. My opinion is not great for something like these, because I'm always going to be like, it's just too loud though. But I'd say I don't mind the noise. All right. It's still hard. I find it hard to spend the money in either one of these. Even though this is so cheap and you could potentially get this one for free. And in this one is because if you just peg your Steam Deck at max RPM, which is quieter than this, right? Which is quieter than this, not quieter than this, but quieter than this, you still get a delta of 8. You know what I'm saying? Like, so if audio is not a big issue for you, there's still no reason to buy this thing, because if you max your Steam Deck out using the Fantastic app with the Decky loader, you're going to get a -8 delta, literally for free, if you don't care about the noise. If noise is not a problem for you, definitely stay tuned. We're going to finish this. I'm going to be giving them out to you, my dearest viewers. But if you can't wait and you don't mind spending the money, you do get a pretty good result. as long as you don't care about noise. That's it. That's like the main thing. Don't care about noise. We were able to get up to 16-degree delta with this, everything max settings. It was super loud. It's freaking ridiculously loud. I would never play it like that, but someone else might not care. Like I said, noise canceling headphones would be great for this. Finally, we created a mod fan, that exhaust fan that actually works. And what I realized in the process of doing that is it's about suction. It's about that air pressure. With a bigger hole, you have less air pressure, so that means that the fans don't have as much suction. So when the fans are in something constrained like this one and this one, you have more suction power with this fan, meaning you're pulling a lot more hot air out of the Steam Deck. So having a smaller enclosure is a lot better than having a big open enclosure. So this was a 4 to 5 degree delta. This was a 3 to 4 degree delta. A delta of, that's a pretty good increase in my opinion, considering how much we paid for all these. So I'm very happy with the results on this, and I can't wait to finalize them so I can start sending them out to you. And I'm not sure how we're going to do that yet. We'll cross that road when we get there. Thank you again for watching. This was a lot of information here, I know, but hopefully you learned a little bit something and learn whether one of these mods or these external fans is something that you would be willing to rock in your Steam Deck. Regardless of my opinion of them, they do work. They work. It's just about the noise. So if that's something that you don't mind, hey man, have at it. Hopefully you win one of these, because this is a lot cheaper than this, and you'll get a little bit of something with our little branding, a little bit more of a part of the community. I love it. But guys, before I get too long-winded, thank you again. Hit that like, hit that sub. Thank you for watching.